Hello, good morning. I know lunch is upon us, so I'll try to be brief. I'm Rukshan Ranadunga. I'm from Swiss Tropical Public Health Institute. We are a non-profit and academic organization based in Switzerland. So today I'm going to talk about automation of clinical guidelines and how we did it for WHO Clinical Care and Crisis Smart Guideline. So propagation of guidelines is a complex process. In average, it takes 3.5 years for a clinical guideline from WHO to propagate into national level. And going that extra mile and taking the clinical guidelines into health information systems takes longer. And to overcome this challenge, WHO has proposed the SMART guideline approach. So what are SMART guidelines? SMART guidelines are standard-based, machine-readable, adaptive, requirement-based, and testable guidelines. WHO has classified SMART guidelines into 5 layers. At layer 1, we have the clinical guidelines that we use every day as clinicians. At layer 2, health informaticians and clinicians get together to create what we call a digital adaptation kit. At the level 3, developers use this digital adaptation kit to create a machine-readable guideline. Currently, these are based on PHIR and CQL to achieve interoperability. At layer 4, these machine-readable guidelines are executed as executable guidelines by applications such as EMRs, mobile applications, and so on. And finally, at layer 5, we have the dynamic guidelines, which are precision-based and AI-based guidelines. So, even though I can explain this in simple terms, the problem is conversion of this digital adaptation kit into machine-readable guidelines is a complex process. So WHO publishes the digital adaptation kit as a document and as sets of large or massive Excel files. So we have 2 options. Either we can do it manually and go line by line and create a machine-readable guideline, or we can automate the process. Doing it manually is time-intensive, it's complex, it's not scalable, and also it can introduce a lot of errors. So this is a screenshot of the digital adaptation kit. So these are massive Excel files, and there are so many. These include the data dictionary, terminologies, the workflows, the software specifications, and so on. So WHO came to us to create a SMART guideline, a machine-readable guideline, and an executable guideline for the clinical care and crisis. So we had the approach of either doing it manually or automating it. So the better option is automation. So when we looked at if there's a tool that we can use to automate the clinical guideline creation, we were surprised to see that there were no such tool to automate. So then we took up the challenge and we said, okay, why not? Let's create a tool to automate the digitalization of the guideline. So our team, we got together and we created a tool called PyFHIR. PyFHIR tool would read these massive digital adaptation kit Excel files and process them and would create the PHIR artifacts, the resources, the CQL queries, the implementation guide. And we were able to create a full pipeline from start to end, the finish, where we would create the implementation guide, which would then trigger a GitHub action or workflow that would generate the implementation guide, publishes it online, which then can be fed into an application to run as an executable guideline. So, as I mentioned, it automates the translation of the digital adaptation kit, it validates if there are any errors in the digital adaptation kit, generates a machine-readable output. It's way easier, it's time efficient, it's flexible, it's scalable. It can be used for future SMART guidelines, it's not just limited for the clinical care and crisis guideline. So the output or the result of it was the WHO Clinical Care and Crisis Implementation Guide. And we were able to use the Android Fire software development kit to execute this machine readable guideline, and we created an Android application which then WHO used in Iraq at crisis settings to deliver quality healthcare to pediatric and neonatal population, and still being used today. So in technologies, we use Python to create PyFHIR. That's why we call it PyFHIR. And we use FHIR shorthand, FHIR standard, CQL, and FHIR implementation guide generator. And finally, GitHub and GitHub workflow for automation and continuous integration and development. So I mentioned some of the advantages earlier. It allows us rapid creation of smart guidelines. This is one of the challenges that smart guidelines face, because even though the steps are easy or it can explain it easily, it's really difficult to create smart guidelines, and that has slowed down the adaptation of smart guidelines globally. Currently, there are only 4 or 5 smart guidelines available at the moment. So we believe a tool like this can rapidly accelerate the creation and adaptation of smart guidelines. Also, it allows you to real-time delivery of changes. For example, if there's a change in the guideline, then we just have to input the new digital adaptation kit, generate the smart guideline, publishes it online, execute it as an executable application. Imagine that having to do it manually. We have to manually go through the code, manually create the FHIR artifacts, which would be so much time consuming. And also, like I said earlier, we can use it for future smart guideline generation. And also we have published it as an open source tool with an unrestricted licensing. So anybody can use this tool for FHIR profiling, for CQL creation, implementation guide generation, and smart guideline creation. So you can customize it and use it any way you want. Although PyFHIR has its advantages, it also has some challenges at the moment, which we are trying to overcome. One of it is PyFHIR is currently a terminal application, so you need some technical skills to operate PyFHIR. Even though we wish we had a web application where users can easily use it, currently we don't have it, but we are working on it. And also we found that even though the digital adaptation kit and these massive Excel files are pretty standardized, we have found there are some irregularities exist in between these Excel files. For example, there may be an additional column, a merged row. So even though we wish we could fully automate it 100%, there was some manual intervention was needed to standardize the Excel files throughout, so it can be used by PyFHIR. And also, since this is a novel approach, we didn't get much developer feedback as we wished. Maybe in future we will be able to get more developer feedback, which we can then use to improve PyFHIR. And finally, the lessons we learned. We found out that translation or creation of digital adaptation kit can have some errors, and this is creation of smart guidelines is an iterative process that requires the input and working together of clinicians, health informaticians, and developers. For example, when we compared the digital adaptation kit to the actual clinical guideline, we found that there are some irregularities, which we then provided as feedback to WHO to correct their digital adaptation kit, which they did. And also we found out that the Android FHIR software development kit lacks some features that require missed features for the proper execution of smart guidelines. So we made feature requests to Google to include these features in the Android FHIR software development kit, and Google was helpful enough to do that. So it was a team effort with clinicians, health practitioners, developers, and the community. And also, smart guidelines and FHIR in general, as we all know, it's a very volatile standard. Things change very rapidly. So in order to keep up to date, we have to keep iterating and keep updating PyFHIR. If not, due to this volatility, in a couple of years, if we don't keep up to date, PyFHIR can be irrelevant. So we hope to have more adaptation from the community, so we can iteratively develop it together as an open source solution, which will propagate the digitalization of guidelines and adaptation of smart guidelines. And finally, we were happy to find out that there's a friendly FHIR community. We were able to reach out to the FHIR side chat group, and they were happy to provide us with feedback when we encountered some errors. And also, Graham is also an active member of FHIR side chat, creator of FHIR, so we worked together to overcome these challenges. So the community was nice. And yes, that now finally, one last thing. What the future holds. So we believe, like, rather than publishing massive Excel files, in future, if we can create these clinical workflows, clinical algorithms in a visual way, such as a flowchart, so clinicians can draw it in a simple way as they create the flowchart, and a tool like PyFHIR can read this flowchart, this diagram, and convert it into an implementation guide. We looked into several different visual paradigms such as PPMN, but we still think that we lack a visual paradigm to correctly represent clinical algorithms. We can go for standard or basic flowcharts, but we found out that flowcharts can be equally complex as the current digital adaptation kit. So we believe, like, in future, there may be a time where we have a visual paradigm to encapsulate clinical decision algorithms. And also, we believe, like, we hope if we can have better developer tools, it will increase adaptation of FHIR and smart guidelines by developers. Currently, even though we have tools for CQL and FHIR, compared to other languages and other developer tools, they are still not mature enough. So maybe if we can have better developer tools, it will increase that developer adaptation. So thank you so much. That concludes my presentation.